Yeah, it kind of looks a little bit intimidating, hey Anna, when you first get into it. You see all these different notation, there's things up and down, you're like, oh my gosh, what's going on? When you actually get into it, it's not hard. The math is, the biggest number you're dealing with is adding or subtracting 4. That's literally as hard as it's going to get. And I shouldn't say that. Once you get into the fission fusion, it gets a little bit harder. For the alpha, beta, gamma stuff though, super easy. Just a few examples, students really can wrap their heads around it, and the math is easy, which is nice. So yeah, it's some good stuff. Cancer is something that we often associate with radiation. And there's 2 reasons we can associate radiation and cancer together. One is that radiation causes cancer, and the second is that we can use radiation to fight cancer, which kind of doesn't make sense because we know that radiation causes it, so why would we use it to fight cancer? But they are both true statements. So we talked about these alpha particles and beta particles and these gamma rays, and I said, oh, if they're ionizing radiation, they can cause you harm. If you inhale alpha particles or inhale something that's emitting alpha radiation, you can get sick. If you are somewhere where there's a lot of beta radiation, it can penetrate your skin, it can make you sick. Somewhere there's gamma, that gamma is going right through you, makes you sick. So what happens is you have this DNA and radiation comes flying along and it goes into one of your cells, and if you're unlucky, the radiation hits the nucleus of your cell where all that DNA lives, and it alters the DNA structure. It breaks it or something like that. So what typically happens is when your cell's DNA gets wrecked, the cell won't be able to replicate any longer, and the cell will just die. That's really common. That's why you get sick when you receive a bunch of radiation, because a bunch of your cells are dying. You're not able to produce blood at appropriate levels. You get sick. So that's kind of what happens. Now, on the off chance that your DNA gets broken at a spot where it's still able to replicate, but the instructions kind of get confused. Remember, these are all pairs. We call them codons. And your body just replicates whatever's there. Sometimes you get into a pattern where it's constantly replicating. The cell just keeps replicating and replicating and replicating and replicating and replicating and replicating. And that's what cancer is. It's a rapid division of cells in your body, and they form what's called tumors. And those tumors can grow everywhere in your body. They can get transported through different systems like lymphatic system or your blood. And the cell's DNA code gets wrecked somehow, sometimes with radiation, and the cell just keeps on replicating. And that's how you get tumors, and that's how you get cancer. So that same idea scientists discovered was a great way to fight cancer by using radiation's ability to kill the DNA or target specific parts of it. Now, what they can do is they take machines and they can focus beams of radiation on really specific areas. And it's common on places like the brain or internal organs, where cutting through the exterior of your brain or an organ to get to the inside isn't a viable option because you're going to damage the organ. So what they do is they take a bunch of beams of radiation and they all target one area. So they focus on one area, and the radiation kills those specific areas where the tumors are growing. So that's how we can use radiation to fight cancer, and that's how radiation causes cancer. Does your body destroy at least one cell every day that otherwise would have become cancer? I don't know. You're literally right now, like millions of cells in my body are dying and being regenerated and duplicated. So it happens so often. I'm thinking that it's possible that, you know, it could happen, but I'm not sure on the sort of statistics of it. We're talking numbers or processes that are so large that it's bound to happen, but I don't know for certain. The other picture above me here is just showing how we have the penetrating power of these things. So an alpha particle stopped by paper, beta stopped by something like aluminum foil, and then gamma is only stopped by lead. So gamma will go through paper and aluminum, and it will be stopped by a lead wall, or several feet of concrete will stop gamma radiation as well. So there you go. There's a video I wanted to watch. It's called A is for Atom. It's one of my favorite science videos ever. I don't know why I love it so much, but I do. It's from 1952. I think they redid it in 53 or 4. And this was like just when people started understanding things about radiation, people started understanding things about nuclear weapons, and that's kind of the period, the setting. So I think it's about 5 to 7 minutes long. What I'm going to do is I'll put the link in the chat and you guys can watch it at home. And if you don't want to watch it, I won't be offended, but I think it's pretty cool. And we'll definitely talk about it a little bit next day. It does such a great job. It makes everything so simple, explaining how these things work. Every time I watch it, I'm like, that makes so much sense. It's just so easy to kind of understand it. So I know it's kind of hard to watch it through the screen with the audio and whatnot. So I'm going to just log onto my other computer here. And I just saw your question there, Alex. Do we have every cell in our body that we were born with? I'd say that some cells get replaced a lot more frequently than others. So things like your neurons in your brain don't get replaced quite as often as, say, something like a skin cell. So I'm not sure exactly on that one. I would suspect that you do have some of the same cells in your body that you were born with, because I know neurons last for a really long time. But it's possible that you don't. I don't know. So you'll definitely be able to Google something like that. It'll come up, I'm sure. All right. So I'm going to leave you with the link in chat. You guys can watch that, and maybe we'll talk a little bit about it at the beginning of next class. Before we go, I had one question for you guys, and it doesn't matter either way for me. We were going to try to go to KSS, or I was going to go to KSS and kind of broadcast out of one of the classrooms there. There's a teacher who was nice enough to invite us in on Monday's class to do some reaction rate stuff with him. So he has some demonstrations with reaction rate. And the problem is that the class starts at, 12:30. So the class wouldn't begin till 12:30. And I know we always do class in the morning. So on Monday, I guess we could go, or I could go to KSS and we could broadcast out of the class, do some more reaction rate sort of demo stuff with him, but it'd be at 12:30. So I was just interested in knowing how many people wouldn't have a problem doing class from 12:30 till maybe an hour and 20 minutes, 12:30 to 1:30, 1:40, we'll say, instead of the morning traditional class. And if you can't, it's fine. I'm not going to be offended or anything, but if everyone says, yeah, that's not a big deal, I guess we could do it at 12:30 instead, then we'll go. We'll pack up the cameras and everything, and we'll head down to KSS and we'll broadcast out of there. But if you guys can't make it, then I would just be, a guy standing in somebody else's room with no one on the other end, and that isn't really worth it. So what we would do is we would just kind of change the schedule up a bit. I'll talk to Mrs. Wood this afternoon and we'll figure it out. And yeah, so it looks like a few of you can, which is good. If you can't, that's fine. Just write it into chat so I'm kind of aware, and that way I know if it's worth it or not. And what we could do as well is do something like, we could have class in the morning, and then for those who want to sign in later, we could do that too. So I kind of like the idea of just having the one class at 12:30 instead of in the morning, but I'll leave it up to you guys. So 1, 2, 3, 4, 5 of you can do 12:30. And if Monday comes and you're like, well, I have something going on or whatever, something comes up, it's not the end of the world, but it'd just be really nice to have you guys on the other end to just see what it's kind of like to do something from a classroom. If it works, we could do more stuff out of a lab, and we might even be able to get into a lab for some of the physics stuff, which I think would be fun. So there you go. 6 of you can, which I think is just about everyone. All right, we'll tentatively plan on it. I'll send you guys a message for sure tomorrow. There's a lot of kind of moving parts, Mr. Ross and then Mr. Wilkinson on the other end, and just getting everything lined up. So if it happens, we'll let you know. We'll assume it's going to. I'll send out dates and times Monday for sure, but an actual time tomorrow or later this afternoon. And if not, we'll just go with the regular schedule. So I'm going to throw this link into chat. There you go. A is for Adam part 1. There's 3 parts to it. Yeah, everything will be the same for you guys, Taylor. You just log into the live stream and the Blackboard, and it'll be all the same. It might be a little bit different because I won't have as many computers to work with and many cameras and things, but we'll see what it's like. We've never done it before. That's why we're kind of looking forward to doing it. So A is for Adam part 1. Don't watch the next couple parts because we need to learn about it still. Or if you do want to watch it, then you'll just be ahead of the class. But I love this video. I don't know why. I would like it if you guys watched it and loved it too. Yeah, that's good. I'm glad you guys are excited about that. It should be interesting. Hopefully we can make it happen. If we can't, we'll try to make it happen again. But yeah, so there you go. That's it. If you can get Unit 5 done by tomorrow, I would appreciate that. Hopefully the next time I see you will be from KSS on Monday. But if not, have a great weekend, guys, and we'll check in sometime tomorrow by email. Thanks. Bye-bye.